So added 0 to it. Now 7 8s are 56. I have a remainder 4. I add a 0. 7 5s are 35. Again I have 5. And you see that it is not ending. And here the numbers are not repeating. Every time you get a different number, right? First you got 1, then 4, then 2, then 8, then 5. I don't know again. Then again if I put 0 here, I get here 7. 749. Then again I get 1. Right? Again I get 1. And then again I put 0. Right? Can you see after this set of numbers, again it comes to the same number. After this set of numbers, again it comes to 1, then again everything will come back. So you find that these numbers are repeating, that is, numbers are different, okay, but they are repeating. And now in the first case, you found that 3 was only one digit which was keeping on repeating and recurring. In this case, it's a bunch of numbers that are repeating. That is, I will have 0. If I have 1 divided by 7, it is represented as 0.142857. And once it comes to again 1, that means its remainder is 1. So the whole thing will once again repeat. So again I will get 2857. So this is a bunch which is repeating. Whole number, this is repeating. That is why even it is non-terminating. Okay, it is non-terminating and recurring, right? Recurring group. It is not one single digit that is recurring. In this case, you found that 3 was a single, or 33, 33, 33. We are very much sure. The next is also 3, 3, 3, 3, 3, 3. But in this case, it's one set, 1, 4, 2, 8, 5, 7, 1. So these sort of numbers, which are terminating with 0, the remainder 0, non-terminating at these two, non-terminating, but are having, it is the same digit is recurring or a group of same digits recurring. All these are examples of rational numbers. They qualify to be called as rational numbers. Okay, they are rational numbers. So whenever you have if I give you a number and I ask you to identify whether it's a rational number or an irrational number. For example, I give you a number 0.57. You can immediately say it is a rational number because it's terminating. There's no digit after it, so it's terminating. Then if I say 1.35 and then I put a bar on this. Okay, I am putting a bar on this. What is going to happen here? If I put a whole bar on this, okay, I am putting a bar on this. So you can say that 35 is a number. It is keeping on repeating. So it is a rational number. Again, if I say 1.35 and on the top I am putting a dash. What does this mean? This is also a rational number because the last digit is keeping on repeating. I know the next digit is all 5, 5, 5. It's also a rational number. Then if I have 1.3672 and I put a bar on this. So this is also a rational number which is repeating. Then if I put 1.3672 and so on, this does not qualify. This does not qualify a rational number because I am not sure whether it is repeating or it is continuously the same digits are coming out. Because here I am very much sure because there's a bar which shows recurring, but here there's no bar on the top, so this does not qualify to be a rational number. This does not qualify to be a rational number, while all the others qualify to be rational numbers. I hope that's clear to you. I hope you can understand when a number is given to you, if it's terminating or if it is recurring, non-terminating but it's recurring, same digits recurring, or a group set recurring, it qualifies to be a rational number, right? That means that number can be represented in the form P by Q, where P and Q are integers and Q not equal to 0. So now let us try to understand with the certain examples which are given in your textbook. Let us take one by one and try to understand how to do that, how to represent a given number or how to prove that a given number is a rational number. Okay, so let's try doing it now. Now the first question, show that 3.142678 is a rational number. This is very much simple. You can write the answer as, you see 1, 2, 3, 4, 5, 6. So you can write the number 3142678 divided by 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So this is the representation of a rational number, because this is an integer, this is an integer, and this is in the form of P by Q, right? In the form of P by Q, where both are integers and Q is how much? 1, 3, 4, 5, 6, which is surely not equal to 0. Which is surely not equal to 0. So this qualifies to be a rational number. So example, if I say represent 1.637 as a rational number in the form, or you can say 31. So how do you represent this? This can be represented as 31637 divided by 1. You have how many decimal digits? 1, 2, 3. 1, 2, 3. So this is the decimal representation. So if I give you an example, so I ask you 317.5628. Show me the rational number representation of this decimal digit. Then you can write it as 3175628 divided by 1. 1, 2, 3, 4. 1, 2, 3, 4. So this is the representation of this number in the form P by Q. And since I can represent this number in the form P by Q, it qualifies to be called a rational number. It qualifies to be called as a rational number. What is the definition of a rational number? A rational number is a number which can be expressed in the form P by Q, where Q is not equal to 0 and P and Q are integers. So this are integers. So this qualifies to be a, so that is how you can represent a given decimal number in the form of P by Q and prove that that number is a rational number. Okay, so again you have to keep in mind whether the given number is terminating, whether the given number is non-terminating but recurring. Either it can be recurring with the same digit or a group of digits recurring, but it's recurring. So when it is recurring and non-terminating or terminating, that's what you've understood. It can be represented in the form P by Q and it qualifies to be a rational number. I hope that clear to you, right? Fine. Now the second question, show 0.33. This is again a recurring number. Is a rational number. So this 0.33 can be represented as this, and you got to prove that it's a rational number. How do you prove this? So now you know that. So let us take 0.333 as equal to x. Okay, what am I doing it? Now in a similar way, let me take an